Daily AI News. Headlines for June 19, 26. Amazon Web Services challenges Nvidia's AI chip dominance by planning to sell Trainium chips externally. AWS AI chief Peter DeSantis confirmed talks with buyers. CEO Andy Jassy noted AWS chip business run rate is $50 billion, versus Nvidia's $326 billion and Intel's $50 billion. AWS kept chips internal, but demand surged. Trainium sold out instantly, as did Trainium 4, unavailable for over a year. Selling externally could strain customers unless AWS boosts TSMC production, which prioritizes Nvidia. Spokesperson Doran Aronson confirmed the possibility. Jassy's $50 billion ambition encroaches on Nvidia's territory. A June 15 Veronese disclosure reveals SearchLeak, a proof-of-concept exfiltration chain in Microsoft 365 Copilot Enterprise Search. A victim clicks a crafted Microsoft.com URL, Copilot searches their mailbox, and data exits via Bing SSRF. No plugins or visible indicators needed. Microsoft rated the flaw critical and patched it on the back end. 4 days earlier, Obsidian Security published a 3CV chain against Lite LLM, escalating a default low-privilege user to admin and remote code execution. The chain includes authorization bypass, privilege escalation, and sandbox escape, assessed at CVSS 9.9. OpenAI researchers found that training AI with small doses of beneficial trait reinforcement learning makes them safer and harder to manipulate. The method uses realistic conversations targeting traits like truthfulness and fairness in healthcare and law. A small mix of this data improved 44 of 53 benchmarks measuring deception, honesty, and sycophancy. Training on health data alone boosted non-health evaluations like reward hacking detection. The model resisted adversarial prompts and harmful fine-tuning, a property called selective persistence. This differs from Anthropic's constitutional method, which uses a written values document. Miami-based startup Subquadratic claims its new model, SubQ, solves a bottleneck limiting large language models. SubQ uses sparse attention instead of dense attention, drastically reducing computations. It has a context window up to 12 million tokens, 12 times larger than most models. On LiveCodeBench, a coding benchmark, SubQ scored 89.7%, matching top models. Appen's independent tests found SubQ 56 times faster than Flash Attention. Running Anthropic's Opus 4.6 on Ruler 128 costs $2,600. SubQ costs $8. Subquadratic says SubQ dynamically selects which token relationships matter, but skeptics await wider release. 2 Nature studies show specialized AI systems rival doctors in simulated cases. Germany's Mira, an autonomous agent in a virtual hospital, chose from over 85,000 options across 11 tools, achieving 87.8% diagnostic accuracy versus 78.1% for specialists. Google's Amy, using a 2-agent architecture, produced appropriate treatment plans in 95% of cases versus 72% for physicians. However, both run on outdated models. Mira uses GPT-4o and o1 Preview, Amy uses Gemini 1.5 Flash. When Google swapped Amy's base model to newer Gemini 2.5 Flash, the specialized scaffolding's advantage nearly vanished. MiniMax released Music 2.6, a major AI music model update. 4 users achieve previously impossible tasks. A Chinese-style video creator generates original BGM with authentic erhu vibrato and flute breaths. An indie game developer composes epic boss music with improved low-frequency clarity. A cafe owner creates custom playlists with a natural, imperfect feel. A daughter uses the cover feature to reimagine her mother's favorite song while preserving its melody. Music 2.6 reduces first packet latency to under 20 seconds, enhances prompt control for BPM, key, and structure, and optimizes low-mid frequencies for house and trap. Researchers from Renmin University of China and Microsoft Research introduced Arbor, a framework that turns AI-driven optimization from trial and error into cumulative learning. Arbor organizes hypotheses, experiments, and insights into a tree structure, letting systems learn from past failures. In tests, Arbor achieved over 2.5 times the verifiable performance gains of standard AI coding agents on real-world engineering tasks, using the same resource budget. This approach automates continuous improvement for complex systems, addressing the bottleneck where agents often produce unwanted improvements without proper state management. Google DeepMind's AI control roadmap treats AI agents as insider threats, granting permissions stepwise based on verified behavior. An analysis of 1 million coding tasks found most flagged issues stem from overzealous agents, not malice. The framework uses MITRE ATT and CK to track risks, with trusted AI supervisors monitoring actions and a prevention system blocking harmful acts. It measures traffic monitored, misconduct caught, and response speed. However, monitoring expires if models learn to hide intentions via oversight awareness or opaque reasoning. The roadmap sorts measures into detection levels D1, D4, and response levels R1, R3. Timage improves multimodal AI by drawing text queries onto images as optimized overlays. It uses a constrained Schrödinger bridge (CSB), an entropic optimal transport sampler with two stages: region search and appearance shaping. Region search transports noise to query-aligned zones while protecting foreground content. Appearance shaping sizes glyphs via an ink budget regularizer for legibility. The overlay acts as an attention beacon for spatial semantics. On VMC Bench, Timage with a 7B backbone achieves 87.7% accuracy, surpassing GPT-4o by 7.4% and Qwen2VL72B by 2.7%. It beats full fine-tuning by 2.5% without modifying weights. Generating realistic humanoid motion from scene images and text involves both low-frequency pose semantics and high-frequency physical dynamics. However, many existing methods tokenize motion with a single shared codebook, forcing heterogeneous motion signals into the same quantization space. Our frequency domain analysis of human motion data reveals a clear mismatch between single codebook quantization and motion statistics. 5 DCT coefficients capture 93% of joint position energy but only 37% of joint velocity energy, which can bias quantization toward pose statistics and underrepresent high-frequency velocity components. Thanks for watching. Hit that like button if you enjoyed today's video. Subscribe to stay updated. And turn on notifications so you never miss out. Let us know in the comments what you think about this video. See you tomorrow for the next daily AI news.